Kia ora 13 MCA. This is a redo of an earlier video that I made that I can't stand listening to because of the stylus noise. So I'm trying to do this using a different microphone and just making less noise with the pen. I'm doing this because this is a really good equation solving task, and I'm just focusing on the second half of the practice task. But just a really quick recap on what we did in the first part. So we've got two functions here. We've got the blue function and we're given that function, and then we had to figure out the equation of the red function. Now that was all what was in video part 1, and I did that pretty slowly, and that video's also got bad stylus noise, but there's a limit to how much redoing I can stand. So the first thing we worked out was that the red function had this equation, and then we did some pretty simple equation work. We had to figure out where was the red function above that line there, y equals 6. And we just had to get particular solutions. So we solved, we did general solutions first because it's so fast. We solved that, and then from there we went and we got a couple of values, and we found that the red function was above that line between these two x coordinates here. Right, so in the second question we have to do something a little bit the same, but the trig equation solving is really quite challenging. So I want you, if you're in my class, make sure that you've got this, and make sure that you're on top of two-step factorizing, because it is such a good technique when we get to hard problems. So in here, we have to investigate for what possible values of x do the two functions have the same value. So this time what I'm going to be doing is equating this one and this one. So I'm going to get into that now, and I'm going to go reasonably quickly, partly because it's a redo, so I'm just looking for my notes. And there are quite a few little things that you've got to notice when you're doing this, right? So the first thing we do is we set up the equations. And we look at that and we notice, well, it's good that we've got sine and sine, but we've got a problem. We've got an x here and we've got an x on 2 here. Happily, one of them is twice as big as the other. So I'm going to replace the x with two lots of half x. So let's rewrite this as 5 sine 2 times x on 2 plus 4 is equal to 10 sine squared x on 2. And right away, just to make things faster, I'm going to let alpha equal x on 2. And that means that I've got 5 sine of 2 alpha in here. So I'm going to do my double angle thing on this, which will give me 10 sine alpha cos alpha plus 4 equals 10 sine squared alpha. Now looking at that, I know that I have to factorize and get a product equaling 0 to get anywhere with solving trig equations. So the first thing I'm going to do is I'm going to divide through everything by 2, and I'm going to subtract everything over to, well, it doesn't really matter which way I go. Let's have a look at what I've done. I'm going to subtract everything over to this side. So we're going to get 0 is equal to 5 sine squared alpha minus 5 sine alpha cos alpha minus 4. Whoops, not minus 4, sorry. First mistake, right, be careful. I'm trying to divide by 2, it's not that hard. Right, so minus 2. Now I'm looking at that and I'm going, I really don't like that minus 2 here. I don't have anything obvious that I can do. I haven't got a nice double angle cosine that I can work with. So I do what I do when I'm desperate, and I'm going to replace this with the Pythagoras identity. Right, and if you've done the old delta work, some of those harder equation solvings and identity questions in there, you'll hopefully remember that that's sometimes, if we're desperate, this is going to help. And you might be able to see how it's going to help already. So here we're going to get, we've got 5 sine squared alpha here, and we've got minus 2 sine squared alpha here. So I am going slightly faster than usual. 3 sine squared alpha minus 5 sine alpha cos alpha. It's an alpha, not an x, minus 2 cos squared alpha. Now, it's kind of hard to see the structure of that quadratic when you're looking at it like that. So let's have the sine of alpha be x and the cos of alpha be y. That gives me 3x squared minus 5xy minus 2y squared. So I'm not liking this much, honestly. I think, this does not feel like a straightforward trig thing to solve, and you're doing quite well if you've got to here, and we're just about there, but we have to figure out a way to factorize this. Now, it's not, we might be able to do it by guess and check, right, because we've got a 3 here and a 2 here. So let's just see if some of you might look at this and you might get it straight away. but I'm going to keep going. I'm not going to tell you what to do here. I've got 3x times x here, and I want to have a plus and a minus here, and there's going to be something with a y, right? Because then it's going to generate this middle term. But we can do our normal year 11 grouping method to make this work. So if you see it, that's really cool. But if you don't see what to do, we're going to go this number times this number, right? The AC method. So something times something has to give me -6, and something plus something has to give me this number here, right? If you've forgotten how to do this, go back and watch one of my level 2 algebra videos on factorizing by grouping, right? I'm not kidding. I'm recommending that. Right, two numbers that times to -6 and have got a gap of -5. So it's going to be something to do with 1 and 6, and I want the negative to go with the 6, right? So 1 times -6 gives me that. So that way, if I haven't spotted what to do, I can break up that middle term as 3x squared minus 6xy plus xy minus 2y squared. And it's fine to work with the x's and y's, right? Then I'm going to box that and factorize that. So 3x into x minus 2y. And now I'm going to box this, and I'm going to get plus y into x minus 2y. And so now it's looking really nice, right? I've got 3x plus y times x minus 2y. And expanding that out, I get 3x squared plus xy minus 6xy minus 2y squared. So we can write that finally. So all of that kind of goes in a big, I guess it's an algebra box that goes out the side. And I'm now going to go back to this equation, and I'm going to write it as a factor. So remember, we've got 0 is equal to that. So moving over here, we've got 0 is equal to 3 sine alpha plus cos alpha times sine alpha minus 2 cos alpha. And all of our hard work is done. The rest, if you got through that, you're definitely going to get through this next bit. Now we've got to say either 3 sine alpha plus cos alpha is 0, or sine alpha, I'll go straight to the next step, sine alpha is equal to 2 cos alpha. And we've got here two tan equations. So 3 sine alpha is equal to negative cos alpha, gives me tan alpha, bringing this across, tan alpha is equal to negative 1/3. Right, so that's next. Here we've got tan of alpha is equal to 2. Right, I'm wondering if anyone actually wants me to keep going on this, but I'm going to, because we just need to be a wee bit careful. So here, alpha is not what we're looking for. We're actually looking for the x on 2. And we do our general solution as usual. And this alpha and this alpha, not the same thing. I really shouldn't have chosen alpha, but whatever. Let's keep going. So alpha is equal to inverse tan of 1/3. So the angle whose tan is 1/3, which is -0.32175. Quickly doing general solutions on that. Guys, I'm actually not going to do the particular solutions on this one. I'm just going to finish the video, and you can do those for yourselves. So the general solutions will be x is equal to 2 n pi minus 0.6435. That's for that one. And similarly for this one, we get alpha is equal to, works out to be 1.107149. And then x is equal to 2 n pi plus 2.2142 is the final step in there. Right now, there are a couple of steps in there that I've just skipped through because I need to go on and do a couple of other trig things today. Okay, so I hope that helps. Go watch part 1 if you need to, if you're in 13 MCA. Part 1 goes through the first bit of that task, and it goes through all of the graphical features for this, and then general solutions and particular solutions. But I think this is the one where most people are going to be hitting trouble with factorizing that equation. Thanks for watching. As usual, please email me if you've got any questions coming up, and I might see some of you on Google Meet later on.